Okay, slightly different topic, but to the same effect, namely, we provide the hazards and you deal with them. I wanted to give you a look both into the past and into the future, what has happened and what will happen. And what do we do with that knowledge? Or what you do with that knowledge. First, some common sense words. TC is telecommunication, and climate change is CC here, is vulnerable to extreme weather events now. And there's only moderate additional impact from climate change to that vulnerability because of the rapid turnover of telecommunications technology. There are exceptions to that. Note, for instance, that sea level rise, if you have a fixed installation, a switching station, a central office that's in a flood zone, that will clearly be a problem. In coastal and tight controlled estuaries. The rapid development of technology allows incremental adaptation to climate change, which other infrastructures that are more stable, transportation, sewer systems, and so on, have not that advantage, don't have that advantage. So that's a good thing for that sector of infrastructure. So what are the key vulnerabilities? Largely storms, hurricanes, snow and ice storms, tornadoes, a little bit lightning, but many of the storms have also in common, not so much in New York City, but in urban and suburban areas, in rural areas, I mean, from falling trees. In coastal areas, increased flooding risk from sea level rise and storm surges will be the main issue, and I will come back to that. It shares the vulnerability with the electric power grid via the items I and B here, and that is one issue that really ought to be more centrally addressed, how for emergencies the telecommunication technology can separate itself and live temporarily on its own. Limited fuel supply at standby backpower, that has been already discussed. That's an obvious thing. But note E in the bottom. Vulnerabilities persist despite all this knowledge due to limited federal FCC and state regulations. That has been argued by the industry, but it also has been argued by the customers. And there is not a solution to that problem. Now, there have been plenty of studies on where the climate will go. One on the left is about, this is all for New York State and New York City. On the left is one 10 years old, and the others are here. We'll focus on these two here in the middle, if it comes, which is the New York City and the New York State reports on the impact of climate change on the city and the state. It is largely the hazards forecasts, but there are also very interesting impact chapters, and I headed the transportation and telecommunication for the state here. So here are some numbers. NPCC stands for the New York Panel on Climate Change. That was commissioned by Mayor Bloomberg, and I was part of that. And it makes forecasts for the baseline is 2000, for the 20s, 50s, and 80s, where the temperatures go, where the precipitation goes, and then the lower two are sea level rise forecasts. And we will really largely, for a moment, deal with these twos in combination, precipitation and temperature together, and then later we will look at some of the sea level rise aspects. When we look at temperature and precipitation, we call that ice and snow. On the upper left, there is a map of New York State, and it shows the number of days with freezing rains. In the lower, you see the snowfall pattern. And many folks think that as the climate gets warmer, we have less freezing rain. Ain't so, folks. And the reason is, as the Great Lakes will not have permanent ice cover in the winter, the winds can pick up more moisture from the water, and they dump all that snow in those areas that are blue here. So there will be actually more snow, even so it's getting warmer, and more freezing rain. Okay? So that's counterintuitive, but it's important to realize that. When either a snowstorm on the upper right or the freezing rain comes, they have very well-known effects. In that snowstorm, you have about 30 days whereby you get back up to 90% of the capacity in terms of customer connection. 30 days. If you run a business, good luck. That's an amazing performance. On the bottom right, it's a little bit faster. It's a freezing rain that was focused on our capital here, Albany, and it came pretty much back within a week. But still, that's a week.
Yeah, that's a long time.
You can't reach where you want. The blue and the yellow is interesting because even the incoming calls of reporting outages, look how they are spread out. People just can't communicate to who needs to know it, that they don't have communication. When you look at this graph, you see that the causes of telecommunications outages is focused on the left-hand side, and it reads commercial and or backup power failure. Now, if for weather or other reasons the power is out, as we all know, sooner or later, depending on which mode of telecommunication you will have outages. There are other things, but that dominates. That's on a national basis. When you then ask, why does the power go out? Then you see that weather-related events dominate the whole power outage scheme. So climate and weather is really an important thing, first for the power grid and then for you as the tele. Now, let's focus on something else. I only look at the so-called rapid ice melt scenario for sea level rise for the 20s, 80s, 50s, and 80s. And you see that that's roughly 1/2 foot, 2 foot, and 4 foot respectively, and that's for New York area. So you say 4 feet, what's the big deal? That's a big deal. Here is the graph. These were some older models on the lower right, and the blue one is what is officially now adopted for New York City, and it ends up with, on average, 5 feet by the end of the century and 6 feet in the upper margin, and as Greenland and Antarctica seem to want to melt faster every day, this may have to be revisited and revised, and those numbers are more likely going up than down. Now, what's the big deal, 5 or 6 feet by the end of the century? Let's just look at this particular row as a function of time. If you are at a height, let's say your switching station, that flooded by a 100-year storm, and now sea level is rising, you need in the year 2000 this much of a storm surge to get to that point. As sea level rises, you need only a small storm. But small storms are more frequent. This is how the recurrence period for what is reached in the past by the 100-year flood. It's 2 years. Every 2 years you will be flooded out just because of sea level rise, even if the storm frequency stays the same. That's untenable if you want to be a world financial center, to be flooded out every 2 years. We had great cooperation with the transportation infrastructure, and so we could map out here in green, right the 100-year in the past, 100-year flood zone, yellow with 2 feet foot sea level rise superimposed, and in green with 4 feet of sea level rise superimposed. That gets you into 2080s. So we know where the water will go. We knew it so well, and with the help of the MTA, who shared their infrastructure data. This is a map not after Sandy. We did this a year before Sandy. They knew exactly which tunnels would flood and where the water would go and what the problems are. If the tele industry would cooperate, we can tell you exactly what happens with your system. But there is all insider knowledge that's not being shared for sometimes good reasons, but it has consequences to the customers. We see where the water goes on the streets. In the past, 100-year storm covered 10%. With 2 foot, it will cover a quarter of the street, and with 4 foot, a third of all streets in New York City, which means all the manholes on those streets, all the basements, all the connections in those will go. This was Sandy. In red, that's the total storm height. It is a combination of the blue wiggly line, which are the tides, and the green, which is the purely storm-produced surge on top of it. They add up to the red. And as you can see, the storm surge and the high tide, one of the high tides, were nicely correlated, and so you got what you got. And on the left, you have one of the switching stations in the left below in Manhattan, of course. This all was totally predictable. Here, what are the adaptation strategies? It's obvious. It's very simple. The question is, who pays for it? Raise a flood-proof infrastructure, central office in particular. Don't put your critical structure into the basement. Put it in the 8th floor or whatever. Tree trimming for icing, education of customers, so they know ahead of time that they have to charge their phones or whatever. Increase fuel supply for backup power. You can go through this list. All these things I have heard just in the last 2 hours since I'm here. There's nothing new in there. It's all doable. The question is, do we know what we need to know in terms of the hazards? Yes. What do we do with that knowledge? I'm listening.